Okay. So in section 2.2, we're going to take a look at polynomial functions. Okay. So we begin with some terminology. A polynomial function of degree n is a function that can be written in the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus so on and so on, a sub 2 x squared, and so forth. Again, and so here our x or our n is going to be a non-negative integer. And then the coefficients a sub n minus 1, a sub n minus 2, a sub n minus 3, so on and so on until we get a sub 2, a sub 1 is 0. These are just real numbers where our a sub n, or our leading coefficient, is not 0. The term a sub n x to the n is called the leading term. So these a sub n's, these are just coefficients. They're just different numbers that go in front of each term. So it's just, and the n is just the indicator to tell us which term we're talking about, like the first, second, third, last, or first, or things of this nature. So we have the leading term, which is our a sub n x to the n, and then the number a sub n, the coefficient of x sub n, is called the leading coefficient, and a naught is called the constant term. A constant function, f of x equals a times x to the 0, is a polynomial of degree 0. So constant functions, we say it has a degree of 0, but then because the 0 function f of x equals 0 can be written in several ways, such as 0 is going to be the same as, we have the 0 times x squared plus 0x, but that's the same as 0 times x to the 5th plus 0, so on and so on, with all these different ways. So no degree is assigned to the 0 function. Okay. So if you've made it this far in the video, I will actually offer an Easter egg at this point. So if you're listening, write down, let's say, that the 0 function has a degree, has no degree assigned to it. So if you send me an email and you say that the 0 function has no degree assigned to it in the subject line, and then just send me an email with your name and that you would like extra credit for today's lecture, I'll give you bonus points for today. So again, as an Easter egg, just send me an email with a subject line that says the 0 function has no degree, and then in your email just put your name and you heard this message and you would like extra credit for being present today. All right, just an Easter egg to kind of see who's doing what. Okay. And I only accept this during class time, or I'll give you maybe 1 or 2 hours before the class is over. So if the class ends at 10:30, I can give you until 12:30 to send that email. Beyond 12:30, I won't accept any emails, because I don't want you to send emails in class. So I'll give you a little time to get out of class and be able to send that. So send me that email. You got 2 hours. By the time we dismiss today, you send it, I'll give you some bonus points. Okay. So anyway, just throwing that in there. Let's see. So the 0 function has no degree assigned to it. So in this section, we focus on polynomial functions of degree 3 or higher. Okay. So let's look at some common properties of polynomial functions. So the domain of a polynomial function is a set of all real numbers. Okay. So when we say the domain, looking at the graph, we would say the very left to the very right. Okay, so how far left does the graph go? How far right does the graph go? So once you identify a function as a polynomial, then the domain is all reals. So another property of polynomials is that the graph of a polynomial function is a continuous curve. This means that the graph has no holes or gaps and can be drawn on a sheet of paper without lifting the pencil. So like on the example, if we look at the below figure, in A, we consider this a continuous curve because we can get from one point on the graph to any other point on the graph without picking our pencil up and stay on the function. But in B, this is an example of something that is a discontinuous curve. And so like if we, for instance, if I tried to trace this, say I started at this point and I wanted to get to something on the right. Now I can trace and trace and trace, but in order to stay on the graph, I'd have to pick my pencil up in order to continue. Or if I go like this, now I'm talking about things that are off the graph. So because we have that gap, this is a discontinuous curve, and so it would not be a polynomial. So this is an example of something that's not a polynomial. Okay. All right. So then the third property is that the graph of a polynomial function is a smooth curve. This means that the graph does not contain any sharp corners. Okay, so looking at these images, a smooth and continuous curve on the left. So again, it's smooth because there are no sharp corners. We can start at any point on the graph and trace it to get to any other point. So that means it's continuous. And then, but if we look on the right example, it's continuous. We can get from one point to any other point on the graph without picking up our pencil, but we have some sharp corners. So polynomials don't have those sharp corners like that. So this is continuous, but it's not smooth. So this is not the graph of a polynomial. So let's look at this example 1. State which functions are polynomial functions. Oh, I need to do my thing. Okay, that's fine. I'll just go with this for now. State which functions are polynomial functions. For each polynomial function, find its degree, the leading term, and the leading coefficient. All right, so just give me a second. I need to do something. All right. And we are back. All right, so we're looking at this example 1. All right, so it says state which functions are polynomial functions. For each function, find a degree. For each polynomial, find its degree, the leading term, and the leading coefficient. Okay. So if we're looking at this, each term, let me see. I'm not seeing anything that would have any restrictions. Like there were no restrictions on the domain. So now, just as a looking ahead, the highest degree here is a 4. Okay. So when we're dealing with, we can say at least with polynomials, say our highest degree is even. So in this case, it's 4. So that means that the end graph behavior, our two tails are going the same direction. So think about it. Like when we have x squared, the two tails go in the same direction. So because this one is even, the far left and the far right are both going to go in the same direction. Right now, we don't know if they go up or down, but we know they go in the same direction. Then we look at the leading coefficient, which is 5, because it's positive. Because it's positive, the right-hand side goes up. So now we know the right-hand side goes up and the left-hand side does the same. So then this one, the graph is going to be, they're both going to go up, and it should be a smooth, continuous curve. So this is a polynomial. You can kind of look at the graph. So we would say, yes, a polynomial. And it's in the form a sub n, x to the n, plus a sub n minus 1. So since we have 3 terms, well, yeah, anyway, it would be a polynomial. Okay. And then with the second one, if you had to think about it, now what I would say is if this wasn't there, then yes, it would be a polynomial. But this restriction says that our domain is from -1 to 5. But one of the properties of polynomials is that the domain is all reals. So because the domain is not all reals, this is not a polynomial.